Every facade begins with a journey that most people never see. The journey of glass, from sand to glass as float glass, that is the main architectural surfaces that define our cities. It all starts with the raw materials. The main ingredient is silica sand, mixed with soda ash and limestone. On their own, these are ordinary minerals, but together, they form the foundation of modern glass. Inside massive industrial furnaces, this mixture is exposed to extreme heat, more than 1500 degrees Celsius. At this temperature, the grains fuse together and become molten glass, a glowing liquid river of energy. The next step is the float process, a breakthrough in glassmaking. The molten glass is gently poured onto a bath of liquid tin. Because of the difference in density, the glass floats and spreads evenly, forming a perfectly flat surface without distortions. This is how modern float glass is born.
And are continuously pushed inside. In the melting zone, the batch of mixed raw materials melts at a temperature of 1550 to 1600 degrees Celsius until it becomes liquid and merges. Melting occurs by heat transfer from the flames located above the glass surface. Chemical reactions between the different elements allow the elaboration of high-quality glass free of bubbles. Flames develop above the furnace. Every 20 minutes, their direction is reversed to optimize the thermal balance in the furnace and the efficiency of the flue gases' heat recovery chambers. In the working end zone, to prepare the spreading of the glass over the tin bath, it is cooled down from 1400 to 1100 degrees Celsius. A cold airflow is regulated for it to precisely reach the temperature and viscosity required at the forming zone. Glass is then ready to leave the melting furnace and enter an enclosed bath of molten tin, literally floating on the molten tin, to become a continuous ribbon of perfect flatness. The edges of the glass puddle are mastered by top rolls machines, which act on the spread surface of the glass. The top rolls effect The second part of the layer is the cooling zone, where, depending on its about 300 degrees Celsius, it becomes possible to lock out the downstream area of the line without impacting its upstream part. This can be useful for maintenance purposes, for instance. The operation, called water break, consists in sprinkling water on the surface of the ribbon to create a thermal shock effect that causes the glass to crack and break. Past the water break point, the layer is not covered anymore. Glass ribbon is continuously checked by a high-performance optical system to detect all kinds of defects. Thanks to the information received by the control system, an automaton maximizes the production of the ribbon. The longitudinal stripes are made by a diamond wheel that creates surface defects on the glass. This prepares the ribbon for the subsequent cut of its edges, thereby removing the top roll marks and obtaining the net width. Then, the traversal stripes will determine the length of the glass plates. In the breakage area, the continuous ribbon is interrupted to form glass plates. The breakage operation consists in a lever effect made by an automatic breakout bar aligned with the transversal cutting line. Next, The edge rollers apply a pressure on the longitudinal cutting lines to trim the glass plates. The edges, together with any glass area not fulfilling the required quality standards, go back into the furnace for recycling. The plate thus formed is then carried by rolls at higher speed to separate it from the continuous ribbon. These final glass sheets are absolutely transparent and have perfectly smooth surfaces. They are